In this module, we will be focusing on the analysis of CVE 2024-5522. This particular vulnerability affects the HTML5 Video Player WordPress plugin versions prior to 2.527. CVE 2024-5522 is a critical security flaw that permits unauthenticated SQL injection, which arises from improper input sanitization and escaping. Understanding this vulnerability is crucial as it exemplifies a common threat faced by web applications. By delving into this case, you will gain insights into the techniques attackers might use and learn the best practices for mitigating SQL injection vulnerabilities. This knowledge is indispensable for developers aiming to bolster the security of their web applications. In this module, we will be analyzing C 2024-5522, which pertains to a significant vulnerability in the HTML5 Video Player WordPress plugin. This particular CVE affects versions prior to 2.527 and involves an unauthenticated SQL injection. The root cause of this issue is improper input sanitization and escaping, which allows attackers to execute arbitrary SQL commands. Understanding this CVE is crucial because it highlights common security shortcomings in web applications using a real-world example. For developers, comprehending how SQL injection vulnerabilities can be introduced and exploiting them will be invaluable for preventing such flaws in their own applications. Through this course, we will dive into the specifics of CVE 2024-5522, grasp its implications, and explore remediation strategies to enhance your secure coding practices. Let's delve into the detailed description of CVE 2024-5522. The affected component is the HTML5 Video Player plugin for WordPress. This vulnerability is particularly concerning as it allows SQL injection via REST route parameter. What this means is that attackers can execute arbitrary SQL commands by exploiting this vulnerability, potentially gaining unauthorized access to sensitive data or performing other malicious activities within the database. The severity of this vulnerability is classified with a CVSS score of 6.5, which is considered medium. This score reflects the potential impact and the exploitability of this vulnerability in real-world scenarios. Understanding the specifics of CVE 2024-5522 is crucial for developers in recognizing common security flaws in web applications and taking steps to mitigate SQL injection vulnerabilities effectively. Now, let's delve into the exploit mechanism of this vulnerability with concrete examples. The critical issue here is that the HTML5 Video Player plugin for WordPress fails to properly sanitize and escape input parameters. This flaw provides an opportunity for attackers to inject malicious SQL commands via REST route parameters. Here's how it works. Attackers craft SQL payloads that are injected directly into the REST route. For instance, using a simple curl command, an attacker can send a request to the vulnerable endpoint. Let's look at two example commands. One girl https:/example.route equals /h5vp/v1/1id equals 1 or plus /bomb/. 2 curl example.com equals /restroute equals h5vp v11id or select one from privacy. In these examples, the injected payload forces the database to execute a sleep function, effectively confirming the presence of the vulnerability when there is a noticeable delay in the response. Attackers can manipulate these payloads to achieve a variety of malicious outcomes, such as extracting sensitive data or performing unauthorized database operations. Understanding this exploit mechanism is crucial in recognizing how the vulnerability can be leveraged and the types of checks necessary to prevent such injections. In this slide, we're focusing on the concept of SQL injection, a prevalent security vulnerability. SQL injection is an attack technique where malicious SQL statements are inserted into an entry field for execution. This can allow attackers to read sensitive data, modify database data, and execute administrative operations, thereby severely compromising the security of the application. The consequences of SQL injection are significant. They can include data exposure, data loss, unauthorized access to the database, and in some cases, complete system compromise. This type of attack is considered so severe that it's ranked as the top issue in web application security, according to the OWASP Top 10, specifically listed as A1 injection. Understanding SQL injection is crucial for developing secure applications and protecting sensitive information from potential threats. Detecting SQL injection vulnerabilities involves both manual testing and automated tools. In manual testing, an attacker might inject payloads directly into the application's entry fields to see how it reacts. Common examples include inputting statements like OR1 equals 1, which always return true, or more destructive commands such as drop table users to delete a table. Automated tools provide another method for detection. Tools like WPScan and SQL Map can scan web applications for vulnerabilities. For instance, WPScan can be used with the command wpscan-urls example.com-enumerate-vp to enumerate vulnerable points, whereas SQL Map is used to identify and exploit SQL injection flaws with commands like example.com/dbs. These methods are essential for identifying weaknesses in your web applications that could lead to serious security breaches. In this slide, we will focus on effective mitigation strategies to prevent SQL injection vulnerabilities in your applications. Firstly, let's talk about sanitization and escaping. It's crucial to always sanitize and escape all user inputs before these inputs are used in SQL queries. This process helps to remove any potentially harmful characters. For example, in PHP, you can use MySQL real escape string to ensure that user input is safe. Here's a quick example. PHP safe input equals MySQL real escape string condol input. Next, we have parameterized queries, also known as prepared statements. These are highly effective in safeguarding against SQL injection. In parameterized queries, user inputs are treated as parameters and not as part of the SQL command, hence preventing them from altering the query's structure. Here is how you can utilize parameterized queries in PHP. PHP stmt =con prepare, select from users where id equals stm bind param I user ID, execute. Using these methods, you can significantly reduce the risk of SQL injection attacks and enhance the security of your database interactions. In this slide, we're focusing on some best practices for secure coding. First and foremost, input validation is crucial. Always validate all inputs against the expected formats and values to ensure that they are legitimate and safe before processing them further. Next, consider the principle of least privilege. This means granting the minimum database permissions necessary for the application to function. This approach helps limit the potential damage an attacker can cause if they do manage to infiltrate your system. Finally, it's essential to conduct regular security audits. Frequent code reviews and security audits help identify vulnerabilities early on, ensuring that potential threats are mitigated before they can be exploited. In this real-world scenario, we're looking at an incident involving an e-commerce website that used a vulnerable plugin. Attackers were able to execute a SQL injection attack, successfully retrieving sensitive customer data. The impact was severe. Personal and payment information of customers was compromised, leading to significant financial losses and reputation damage for the company involved. The key lesson here is the importance of continuous monitoring and timely updates. Had the plugin been properly updated and monitored, the vulnerability might have been patched before it could be exploited. This scenario underscores the critical need for vigilance in maintaining the security of your applications. Let's wrap up with some key takeaways from our session. Firstly, it's essential to understand the nature of SQL injection and the significant impacts it can have on your systems and data. SQL injection can lead to severe breaches, compromising both personal and payment information, thus leading to financial losses and reputation damage, as we've seen in our real-world scenario. Next, emphasis on proper input sanitization. Escaping and utilizing prepared statements can't be overstated. These practices are critical in preventing SQL injection vulnerabilities. Regular updates and audits of your applications are pivotal to stay ahead of potential threats. For further reading, I highly recommend the OWASP SQL Injection Guide. It provides in-depth knowledge on the subject. Additionally, consider looking into practical recommendations for secure coding in PHP and other languages to bolster your defenses. By following these guidelines, you can significantly reduce the risk of exploitation and safeguard your systems effectively. On this slide, we have 3 key references that you can explore for further details on the discussed SQL injection topic and related vulnerabilities. 1. The National Vulnerability Database, NVD. Here, you can find detailed information about the common vulnerabilities and exposures, CVE, identified as CVE 2024-5522. This resource is invaluable for understanding the technical specifics and potential impacts of this particular vulnerability. Number 2. WPScan Vulnerability Report. This report provides insights into vulnerabilities within WordPress plugins and themes. It is an excellent resource for those working within the WordPress ecosystem or managing sites built on WordPress. The particular vulnerability, CVE 2024-5522, is discussed in this report, offering further practical information. 3. GitHub Proof of Concept, POC. For a more hands-on perspective, you can review the proof of concept for CVE 2024-5522 available on GitHub. This POC demonstrates how the vulnerability can be exploited, providing a clearer understanding of its practical implications and aiding in testing your own environments. Each of these references can provide further depth and context, helping you solidify your understanding of SQL injection risks and the necessary mitigation steps. Thank you for reaching the end of this course. Did you find the content useful and informative? If so, please leave a like to show your support. Your feedback is invaluable, so feel free to comment below with your thoughts or any questions you might have. Don't forget to subscribe to the channel to stay updated with the latest courses and tutorials. Finally, sharing this content with friends and colleagues can help others learn and benefit as well. Thank you for your engagement.